7. Welcome back to math class, where we're going to be taking a look at solving equations today. I'm going to begin by starting with a very simple equation. X plus 2 equals 4. And you're looking at that and you're saying, well, x is 2. Why are we bothering with it? And I agree, this is a very simple one. But we're going to start with a simple one where we can see that it works to introduce a new method, a way of thinking through equations that will allow us to move to a pretty high level of complexity, and you'll still be able to get to the correct answer. So let's take a look at what it's all about. Well, first of all, what I've represented here is like a balance scale. Here's our pivot point, and you could imagine if this side were heavier, it would sink down. But since it's nice and horizontal and balanced, we know that whatever appears here must be equal in value to whatever appears here. That really is the definition of what math means with equals, that this half has the same value as this half over here. So what's the method? Well, I've sort of captured it here, but some of this is going to seem like jargon initially. But let's start with this. It says isolate the variable. Now that word isolate, you may think of isolation, being alone on a desert island. Well, that's what it's all about. To isolate the variable is to get it on its own. If we can get x alone on this side and not affect the balance, then we could just look over here and we would know exactly what its value is because it would balance out. And you can see right away what is making this difficult. Well, we've got an extra 2 over here. So we need to get rid of them. This is where we get to this first idea here. Reverse whatever is happening to your variable right now. Well, look. 2 is being added to the variable. We want to do the opposite. Over here, I've written a double slash. This is a way in math of indicating that what you're writing down what you intend to do to both sides of your balance. So double slash subtract 2 means my intention is to take 2 away from both sides. So let's do that work now. In order to do this, I'm going to grab these 2 guys, and I'm going to delete them. Now, if I left it like that, this side would be heavier and would sink down. But by doing the same action to both sides, I can keep it balanced. And now we've accomplished this idea of isolating the variable. It's here on its own. All we have to do is look on this side to know exactly its value. And sure enough, yes, x is 2. Now, as a good habit of mind and practice, once we determine the value of a variable, we should always check that we got it right. We do that by taking our value and substituting back into the original equation to see if we were right. I've done that work over here. I've rewritten the original equation. Here I have put our solution of x equals 2 into the x variable, solved it, and came up with an equality. And when that happens, we know we got it right. Now, the part we haven't really looked at yet is the idea of doing BEDMAS in reverse. But we'll get to that shortly after we consider reversing what's happening to your variable in another situation. So let me move us to another spot here. And we'll take a look at a second equation. Also a fairly simple one, but a little bit different. So here we go. Now the equation is 2x equals 4. Remember that when we have no sign in between here, what we really mean is this is 2 times x. And that's exactly what we have on this side of the balance. 2 times this thing called x. And we're saying it's equal to 4, which is represented here. Everything's balanced, so we have an equality. Now, remember that the strategy said to reverse whatever is currently being done to x. Well, x is right now being multiplied by 2. So beside my double slash, I say my intention then is to divide both sides by 2. Now, if I do that, I have a group of 2. I need to divide amongst, let's say, 2 people. How much would each person get? Well, they would get 1. So that's what's left here, is the 1. Similarly here, if I had 4 things divided amongst 2 people, each person would get 2. So that's what I have left. And once again, I have an isolated variable. I can look at this side to see its value, and indeed, x is 2. Once again, as a good habit and good practice, I've rewritten the equation, substituted in my solution for x here, and it turns out to be true, so I know I had the right solution for x. So now it's time to get back to the method, and this time we're going to introduce the idea of reverse BEDMAS. So we're going to take a look at another somewhat more complicated situation. Well, I don't think it's too bad. But let's take a look at this. So here my equation is 3x plus 2 equals 8. Remembering that this really means 3 times x. And it's been represented over here. Here are my 3 x's. Here is the plus 2. And here are the 8. Now, our strategy says reverse what's being done to x at the present moment. Well, it's being multiplied by 3, but it's also having 2 added. This is where reverse BEDMAS comes into play. When you are trying to isolate a variable, you don't do things in the order of BEDMAS, you do it in the exact reverse. BEDMAS would tell us to deal with multiplying first and then deal with adding. But when isolating a variable, we do the exact opposite and we deal with this part first. So what is the opposite of adding 2? Well, it's subtracting 2. And to keep the weight scale balanced, we have to do it to both sides. You can see that represented here. The 2 have been taken away here, and the 2 from the top have been taken away here. So we still have a nice balance, but now things are a lot simpler. We have that 3x equals 6. So now we need to get back to that step just before the reverse BEDMAS where we reverse the operation. So here, x is being multiplied by 3. What is the opposite of that? Well, it's dividing by 3, of course, and here we write our intention is to divide both sides by 3 in order to keep things balanced. I would like to, for a moment, consider with you what division really means. And I understand that for some of you this won't be entirely necessary, but I think for some it will. You can always skip ahead a little bit if you need to. Let's look at what this idea of dividing means. If I say 9 divided by 3, what I mean is that I'm taking this group of 9 things and I'm splitting it up into 3 groups. And then I'm asking myself, how much is in each group? Well, there are 3. That's what 9 divided by 3 means. It means how much is in each of the 3 groups. So let's have that in mind as we come back to our main equation over here. When I divide my 3x's by 3, I'm really splitting it up into 3 different groups and asking how much is in each group. And you can see here there's 1 in each of my groups, and so that's what ends up on my balance on the left-hand side. When I divide this side by 3, I'm breaking it up into 3 groups, and I'm asking how much is in one of those 3 groups. Well, there are 2 in there, and that's what ends up on this side. And once again, our solution is that x equals 2. Now, as a good habit, we need to always check our work, so I've done that up here. I've taken the solution of x is 2, and I've substituted it into the variable here. So I now have 3 times 2 plus 2 equals 8. Now, when we're checking, remember we are no longer isolating a variable, and therefore we're back to the normal order of BEDMAS. So I do my multiplying first. I get the 6 plus 2 equals 8. Then I add. I have an equality. I know I found the right value for x. Okay, so at this point, we'll do away with the balance system, and we'll just do it mathematically. Let's keep in mind we always want to isolate the variable. We want to get it by itself. And we accomplish this with reverse operations in reverse BEDMAS. So let's begin here. We have the fraction z over 4 plus 5 equals 17. And recall that every fraction is really a division statement. So 2 things being done to z. It's being divided by 4, and 5 is being added. And we want to undo what's being done to z in order to isolate it. So between adding and dividing, we would normally divide first, but we're in reverse BEDMAS, so we'll deal with the adding first. This means that to undo adding, I need to subtract that 5 from both sides. Well, that leaves me with just the fraction over here on this side, and 17 minus 5 is 12. So it's already gotten a lot simpler. And now I need to deal with the division that's going on here. And to reverse that division, that's right, I need to use multiplication. So I'll multiply by 4 both sides. This automatically isolates z for us, because if you divide z by 4 and then multiply by 4 again, you're just right down to z. And to keep things balanced, we multiply this by 4 as well and get 48. I've also shown over here how I go about making sure that I got the right solution. So I take my 48 value that I got for z and I put it in the place of z, which you can see here. Now that we are no longer isolating a variable, we're in normal BEDMAS, so we'll do the dividing first. That gives us 12 plus 5, and there we have an equality. We know it worked. Let's take a look at one more just to reinforce the idea. I've actually changed the order just to show you that you can change things around a little bit and it will still work the same way. So here, my variable f, which I would like to isolate, is being multiplied by 2, and 7 is being added. And yes, we need to deal with the 7 first. So let's subtract 7 from both sides. 15 minus 7 is 8, and this whole thing minus the 7 is just the 2f part. So remember that 2f really means 2 times f, and to undo multiplying, I need to use division. So I will divide that. Let me just quickly find the symbol for you. I will divide that by the 2, and I have to do that to both sides, of course. 8 divided by 2 is 4. 2f divided by 2 is f. Here's my solution. F is 4. Again, I substitute it into the original equation, do my normal solving with normal BEDMAS, the multiplication before the adding, and we get 15 equals 15, and it worked. So we found the correct solution. Okay, your assignment today will involve a Google Doc that has a bunch of equations in it that you will use this method to solve. And this shows you all the work that's expected for each question. This is entirely enough to show. Okay, hope it goes well today. Bye for now. You see, it's just that easy.